Hello. Right, number 9. Ah, more time has passed. Another while, as things are. Right, let's do this. So, last time, I did one of these. It was like a week ago. Can't exactly remember what I was working on then. I'm pretty sure I said I was going to be doing some gameplay-related stuff. And I did. And then immediately got interrupted by more work. So, today, we're going to be talking about netcode and RPCs and remote procedure calls. So that's what an RPC is. So, summary, let's go over this. On Thursday, I said to myself, hey, I want to add enemies into my game that are kind of, just randomly static enemies around the map, right? And I want it so that when you walk towards them, they aggro onto you, and so they'll follow you. And then once you get out of their aggro range, they walk back to that spot, right? And when you defeat this group of enemies, right, and there'll be some sort of a way to know that they're in a group, they drop a reward for you, right? So this is a pretty standard thing, right? It's like a little challenge spot on the map. So some nice little gameplay to look at when you start the run and to chase after them. However, when I tried to implement that, I ran into a few issues. So the first one is that actually linking entities in my game is not very easy. So I'll show you. Let's imagine that we have this it's gonna be a little hard to see, but this is a group of enemies. Hello, Idle. This, sorry. Okay, this is a group of enemies. And the idea is that I've got on this thing an entity grouping authoring so that the entities inside of this group actually get grouped. However, I can't store entity IDs because of my save system, right? Any entity ID is different on different platforms, and I don't really have a good reliable way to like create an entity ID mapping thing. Just because I didn't write the save system that I'm using, and it's just ended up having some problems. So the workaround to that is that this entity grouping thing, when the actual when this thing is placed in the world, the next frame, this entity grouping thing kind of takes a snapshot of everything in its radius, deletes itself, and then kind of calls all of those entities underneath it grouped, right? And so we can look at that. So if we have a look at the code for this, we've got this entity grouping authoring thing. I add in the entity grouping, I set it to disabled, so that this means that certain systems can kind of like look for this and only run when this is disabled, or only run when this is enabled. And then some more like tag things. So destroy when children is 0. I can add this as a component to the parent. So like if it doesn't have any children, it's just gonna explode and drop its reward. And finally, a buffer of all of the entities that are linked to this. So if we actually go to the system itself, right? I have a few different parts. So we have this setup entity groups, and what this is going to do is that it goes over all of the groups that are currently disabled, and then it tries to enable them. It'll do a collision check on the enemy collider tree, and when it so this is the visitor thing. This is actually like, it's a struct that gets executed on every single thing that it visits, and you can see that here. So a penta buffer. So to the parent, I add a reference to the child's network ID. So this is a reference value that can be shared between the save. So the client and server don't desync about this. And also, I add to the child a reference to the parent. And then potentially I tell the child to die when the parent is null. So that's one part of this. Then I update entity groups. So this method just make sure it removes links when the children are destroyed. So from the parent like group object, it'll like make sure that the links actually exist inside of the network map, the network ID mapping. And so the network ID mapping is a mapping of all IDs to their entities for that particular game, right? So on the server and the client, they're gonna have the same keys, but their values are gonna be different. And this is generated inside of an overly complicated system that I made. And then finally, we do delete empty groups job. So this is this deletes entity groups that are destroyed when all the children's 0. And so it'll go like, okay, if destroy entity group because no children found. I probably don't need to do this part because this actually gets checked, but we'll fix that later. And also entity grouping destroy when parent null. So delete empty group linked job. And so this actually goes to the children and then destroys them if their parent is not in the mapping. Yeah. And so that's cool. This took a while to implement, not because it was complicated, but because of bugs, right? I did not have a good way to quickly test this thing because I needed to do some very specific actions to test this, and we can have a look at the testing. So, the main thing that I needed to do to test is I needed to place this thing in the world, right? During runtime. And then I needed to actually, destroy the children and make sure the parent got destroyed. Or destroy the parent and make sure the children got destroyed. Right? And for those things, I needed to make an entire RPC, or an entire specific server call. And before, they were not structs. So now you can see what it looks like. And it's like, okay, so admin place event RPC. Ooh, relax, music, relax. Admin place event RPC, right? It's very simple. And then there's the actual execution down here. We'll get to why it's kind of laid out like this in a bit. But yeah, so this is new. This used to not look nearly as nice. So I'll show you what it used to look like before. So okay, reworking RPCs. So I can't open this version of it. That's okay. So how the RPCs used to work is I had an enum for what RPC it was, and then all of them shared the same actual data, right? And I was using what is effectively like a C union to have the same bytes of data be usable for multiple different types. So you can see field offset 0 byte type, field offset 0. I mean this seems like a no. This is correct, yeah. And there's some more stuff here, right? So like field offset 2 is private lobby, field offset 2 invited player ID. Like I'm using the same bytes for multiple things here. This was a huge pain to write because I'd need to add the enum, I'd need to add the actual construction methods, this static method. I'd have to add the field offset stuff and keep track of that. Multiple of these things were sharing different values. It was a huge pain. And then the actual execute method was this big game RPC system, and I had a case for every single implementation. So 3 different spots. It was really annoying if I wanted to actually edit any of the code for the actual RPC structure itself. Yeah, so this wasn't good. So now we have a nice, proper implementation that's probably far too complicated. We're gonna go over this. So, how the RPCs work is every single frame, every client will send their inputs to the server, and the server will send one big packet with all of the inputs from the players and the number of RPCs and all of the RPC data back to the players, and then the players get to execute that locally, and so everyone executes the same stuff the same way, hopefully, right? Otherwise we get desyncs and I have to do way more testing on that, but whatever. And we can actually see inside of the network system kind of roughly what that looks like. So if we have a look at ping server behavior, this one, that is really getting in my way, stopping me from moving my other hand. We'll go down here to come on. I just gotta try and find where I actually distribute the steps. Okay, apply step. So new step data, full step. So full step data is this thing. Yeah, so this is the full step data. So step, checksum, extra actions. So these are the RPCs. And then P, this is the inputs for each individual player, right? And so the actual input like object looks like this, right? So it's about probably what, 64 bytes? Yeah, 64 bytes long, with like a bunch of space to be able to handle different things. And yeah, so this is one full step. And the actual RPCs are sent like separately, I guess. So we can look at this, M special actions list. If I find all references, then I'm going to be passing this into a job. So yeah, special actions. And yeah, so I write client, special actions. Yeah, so I write out I send the special actions to the clients as well. So when they receive the RPCs, they actually need to add them to the game themselves, right? This is a whole process. I should probably make a diagram for this, but I'm not very good at doodling. So we have this apply method. If we have a look at the calls for this, when we actually apply the step data, right? So we apply the inputs and the extra actions. What we do is we go, okay, if there are any RPCs in this thing, then we're going to apply each of them individually, so one by one, right? And the ordering should be the same on every player, which is not important. And for each of these, we actually create an entity, like a game RPC entity, and we set their data to the actual game RPC, right? And you may notice, wait a second, this game RPC, it's still an unmanaged struct, which it needs to be. But before the RPC that you were using, this thing, it's not that. It's very strange that you're able to do that. And the secret is that I'm encoding the RPC like data inside of this section here. So fixed byte data size. All my RPCs are at max 64 bytes, right? Or no, 32 bytes. And I put all of the actual RPC information inside of this tiny little section here. And there's like some there's extra information for the RPC wrapper here, but then the RPC like execution method is stored inside of this. Yeah. Okay, sorry, we're not done yet. When this is actually executed, right? We can see, hold up, trying to find it. Yeah, so the actual execution is done inside of this thing called the Game RPC System 2, because this is the second RPC system I've implemented. And we just get all of the RPCs from the game, so this can be done really fast. This could probably be jobified as well, or the individual methods can be jobified. And then for each RPC, we try to execute them. We get the RPC type index. Get to this in a second as well. We switch over it to determine which RPC it is, which is it's very similar to what I was doing before. And then we execute a particular method for that RPC, right? And we we run it, right? We're like reinterpreting the RPC data. So you can see here, data pointer, return, and then it just does a typecast to the actual unmanaged RPC type. Yeah, and we execute it. This whole file is generated. Please ignore that email noise. This whole file is generated. So we can see up here, I've got a bunch of generated index, generated size, and this is just for this one. And I do this for every single one of them. I also have this lookup table so that we can access them from index as well, so like kind of back reference them. So, because you can get the index for the type, but you can also get the type for the index. This stuff won't work during any burst compiled code because, well, this array is a the type alone is managed, so we can't use this thing here or there. But yeah, so this is all generated. And that means that the only thing I actually have to do is write this, right? And the way that I generate that file, to save myself the trouble of having to do like all of those extra things, and still have it be efficient, and be able to access the system API, which I cannot use if this execute method was inside of this struct, is I make sure that the game is able to compile even if that generated code doesn't exist, right? And this is very similar to how Unity's jobs and entities code works and compiles, right? Or the code generation for it works, is everything that you write is still functional even if the generated code doesn't exist, and so you don't get any squiggly lines or anything like that. But like, during runtime, nothing would work. But that doesn't matter, because before you play the game, you're gonna make sure that the code that you actually need is generated. So all of this works even if there's no generated code, but or it all compiles even if there's no generated code, but it doesn't run unless there's generated code. And because this all compiles, that means that inside of the editor, after it compiles everything, I then have access to like type reflection and stuff, so I can find every single type that inherits from iGameRPC, and I can generate code for that really easily. I don't have to look inside of any of the files. I can just use the actual assembly that's generated and all the type information and stuff, and regular C# reflection, which if you've used a lot of C#, you'll know is like really, really handy to generate the files. And I'll show you what that looks like. So I have this RPC rebuilder class. I have a method to delete all the RPC code, and the RPC generated code is actually placed inside of the assets. So I have to do like some asset database refresh calls and stuff to make sure that the editor knows when the files are deleted or when the files are added, because otherwise there can be little issues. This also doesn't exactly work perfectly, so don't copy this. And then, to generate all the RPC code, we're gonna make sure that there's no compile errors, right? The old code should probably be deleted, but it doesn't really need to be. And we go over all the assemblies, we find everything that is assignable from iGameRPC, we determine some information of it. So we can fortunately use okay, this is a little silly, but we use the unsafe size of method to determine the size of the type, which is handy to kind of like debug things and to make sure that I don't have an RPC that is larger than the maximum size or the size of the RPCs that I've like designated, right? Again, we'll go back to this, and because this has a very fixed this has a fixed size of 32 bytes, right? Unless I change it, and I can change it if I end up making an RPC that's too big, right? Yeah. So I also generate the index based off of how many RPCs that I've generated so far, and then I generate a big code file, right? So I've got the code here. You can use this @ symbol to actually like just be able to type enters. Very handy. So we got the usings. We have for every single RPC, I generate the other partial part of their struct. So you can see public, unsafe, partial struct, the actual type. I get the index and the size as constants, so I can access them during runtime, which is really nice. This reverse lookup, which is an override for the interface, like a base method that the interfaces all use. Then we've got the lookup table, which I generate as well. So I just pass in all of the values again. And then finally the actual system, which gets generated. So there's this big setup at the start, right? Sets up an ECV, does a bunch of stuff, whatever, execution, switch, and then this is where the actual execute thing is added, right? And I'll throw a warning if I try to generate this, or it'll give me compile errors if I generate the file and the execute method reffing this particular type doesn't exist, right? So we can use that to find out like, oh hey, there's still books. And now with all of that, I have nice RPCs that I can use, and I can go back to doing nice tests. And so I made this destroy network ID RPC to test this thing. It's the stupid Malcolm in the Middle meme of the guy going around the house and a billion different problems, and yeah. So yeah, that's what I've been working on for the last few days. And I'm very happy with this implementation. I think this change has saved me a lot of time. Whatever. Yeah. So the next step now is to finish doing the testing for this. I can run this entity grouping test, and if I do, get me out of this. So if I run this, I'm currently getting some desyncs when I execute this. So the test this test in particular is using a method that I wrote that allows me to test in like the single player case, in the multiplayer case where it executes some code before a player joins, and then checks for a desync after they join, or it runs some code before they join, has them join, some more code after they join, and then tests for desync, as well as has the player join, runs all the code, and then tests for desync, right? So all of these three different cases are tested now, which is really handy because, well, it helped me find this desync, where apparently some network IDs are like getting destroyed, or they never existed in the first place, or something like that, on the client. Yeah, and so I need to fix this up, and then everything's gonna be hunky-dory, and I can keep adding in more gameplay, hopefully. So today, bug fixing on this unit test, as well as trying to get as much gameplay implemented as possible. Pray for me that I can actually get a playable demo by Friday this week. That's... please, Lord. Yeah. Alright. Thank you for watching. Bye-bye.